Hey, what's up? Mr. Paul here, and we're gonna take a look at this, what I call the double trick problem. Let's just do it. As modeled below, a movie is projected onto a large outdoor screen. The bottom of the 60-foot tall screen is 12 feet off the ground. The projector sits on the ground at a horizontal distance of 75 feet from the screen. Alright, so let's just see what we have here so far. So this over here is the screen. Well, this piece here is at 12 feet off the ground, but the 60 up here is definitely the screen. And let's just see what they're trying to ask us. Determine theta to the nearest tenth of a degree, the measure of theta, the projection angle. So they want to know what this angle here is. Now, we're going to look at two different triangles here. And the first one, can I change the color of this? I don't know. Alright, so the first one is, now we're going to use Trig to do this, and in order to use Trig, you need to have right triangles. So we're looking at this red right triangle, and then we're going to look at this green right triangle. Right? Obviously, this is a right angle right there. Alright. Now, please note, for the big red triangle, this is your angle, the whole thing. So it's theta plus this little extra thing here. But that little extra angle belongs to the green triangle. So if we could figure out, and we can, the big red reference angle and the small green reference angle, we just subtract them and we got theta. So let's actually do that. So I'm looking at the green triangle with respect to, let's call that angle A, and let's call the other reference angle B. So with respect to angle, let's do the green one first, the tiny triangle. So I'm just gonna draw the triangle here again. So this is angle A, and we have 12 and 75. And this is a tangent problem because this is opposite and this is adjacent. And we know so, ka, toa. And we have opposite and adjacent, so we got to use tangent. So this is tangent of the angle A is equal to opposite, which is 12, over adjacent, which is 75. And you can work that out. Let's do the right triangle now. So same thing. This is angle B. And now this length is actually 72 because you have to add the 60 and the 12. And the distance over here is still 75. So this is still tangent because we have opposite and adjacent. So it's tangent of B is equal to opposite over adjacent. And when you're looking for the angle, remember you have to do the inverse. And the way I like to kind of show you guys is like you take the inverse of this thing and you mean with A. And you take the inverse as well, tangent of this thing. And well, then you could just write it the way it's supposed to be. And let's write the red one. So invert that. So the way I think about it is that the inverse tangent and the tangent cancels, and your main would be. But canceling is definitely the wrong word to use there. I wouldn't really say that in real life. So don't let anybody hear you saying that. 72 over 75. And I'm going to pause this and pull up my calculator real quick. Alright, so we're going to do the inverse tan of 12 over 75. So second tan, 12 over 75, close parentheses. Oh, okay. So this is a good way to show you. If you look at the top, you'll see that I'm in radian mode. You gotta click mode. And we're dealing with degrees. So don't forget to switch over to degrees. And let's kind of do that again. So quit back to that screen. Let's enter this again. And there we go. So I forgot what the problem says. So we're going to kind of remember a few digits here. I wonder if I could select this and could I copy this? All right, so I'm not sure how to copy this. So we'll just remember 9.09027. So A is approximately 9.09027. And now let's figure out what B is. So this is the inverse tan of 72 over 75. Inverse tan of 72 over 75. And you get 43.83086. 43.83086. 43 point what? 83086. 83086. Okay, so I didn't even round. I just kind of like truncate the numbers, which means I cut the number short. But I have so many decimals that I'm not going to make any rounding errors. And you can clearly see over here that it says to round to the nearest tenth of a degree. So don't forget that these were all in degrees. I actually kind of forgot about that. So now we just have to subtract them. So angle B minus angle A should give us theta. And I'm just going to do that on the calculator. So I didn't actually even need to write down the numbers because I'm just going to do this. That's a big angle minus this. That's a small angle. And we get roughly 34.7 degrees. And it does say the nearest tenth. So theta is approximately 34.7 degrees.